Respected viewers, welcome to Theory of Computation. Myself Dr. Venkatesh, working as a assistant professor in the Department of Computer Science and Engineering, School of CS and AI, SR University, Warangal, Telangana. So today we will discuss the theory of the computation. So we will before going to the actual content, we will discuss the syllabus, then followed by the syllabus and followed by the remaining concepts. So first unit 1 we will discuss the automata and followed by the its properties, regular expressions and regular expression properties are from regular expression to the automata conversion, etc. we will discuss. And unit number 2 we will discuss the context free languages, types of context free grammars and ambiguity of the context free language, parsing concept, PDA. And unit 3 we will discuss about the Turing mission, decidability, undecidability, halting problems. So at the end we will discuss the NP and PNP problems. So next, before going to the actual content of the today lecture, we will go the outline of the our presentation. First one is we will discuss the introduction and followed by the automata definition and practical applications of the automata and sets. Next we will discuss the strings followed by the alphabets, formal definition of the automata. At end of the today lecture we will discuss about the examples of the automata. So first one, introduction. So what is a automata? We will discuss the formal definition later on. First we will discuss the what is automata. Automata is a abstract machine. It is a abstract machine that model how the system process input and states. We can say simply automata is an abstract model. It is a type of computing device. So if you are giving input, it will change the one state to the another state, depends on the input. We can say simply automata is a abstract model, and they can help to analyze the computation, recognize the patterns. So that means that it will analyze the computation. We will discuss the more details later on some going lectures. So recognize the patterns and validate the formal languages. What is a language? How do we validate? All those things we will discuss on the some point of time. That means that not today lecture. We will discuss the after 4-5 classes. We will understand the more details and coming lectures. And we can say at the final point, we can say automata is a core foundation of theoretical computer science. You can say it is a theoretical computer science. That means that automata is a foundation stone for development of the computer science. It much more useful in compilers, AI and system design. So we can say it is a automata is a theoretical foundation stone for computer science. So we will discuss how it is helpful and all these things in further classes. So next one, applications of the automata. So first one is a compiler design. What is a compiler design? Everyone know a computer will not understand the human language like English and some other languages. What the computer will understand? Computer will understand from zeros and ones only, right? So understand the zeros and ones. The compiler will translate the machine level language to the computer will compiler will translate the human readable language to the machine readable language, that is a zeros and ones. There we will use the automata. So this is the one of the application in the automata. Second one is a pattern matching, right. Here it is a pattern matching. Pattern matching means it is a help in search text pattern and a search engine and spelling checkers. So here you can see search in Google is a search engine. It will check the, if you type something, it will check the pattern and match the relevant content will be delivered. So next one is a network protocol verification. So that is a third application of the automata, that is a network protocol verification. So it ensure the correct communication between the device and modeling protocol states. So that means that it will ensure the correct communication between the devices. That means that if you want to communicate one device to the another device, it will ensure the whether the data is coming from particular device or not. So this is the one kind of verification in the network protocol. And final one is a final and last, not to last one, that is a AI and robotics. Decision making process it will use. Last one is a digital circuit design. So those who are computers and EC people, they might know what is a digital circuit and all those things. It will be used in the design sequential circuit, control, logic boards, hardware system, something like that. So it is not in a digital logic design subject. So I am not going to discuss about much more details in the this related details. Next one is a sets. Everyone know high school mathematics. Set is a well defined collection of distinct objects or elements. So that means that set is a well defined collection of distinct objects. So that means that it might be the collection of elements. We can say simple elements. It will be represented in a form of curly braces. Example we can see here. It is a is a one set, 1, 2, 3, 4, 5, right. So next is a alphabet set. I try to understand here. First is a set. Second one is a alphabet set. So what is a set? It is a well defined collection of distinct object. Second one is a alphabet set. Alphabet is a finite non-empty set of symbols used from strings, example 0 or 1. So now you can see here alphabet set, right. Set means here well defined structure, alphabet means it is a 0 and 1 is a one of the alphabet set. Simple we can say simple. Strings which is forming using the 0 or 1 is a alphabet set. That means that if you are using 0, 1 is a one kind of set. So what is the set strings we can form? That is a 0, 1, 1, 0, 1, 1, 1, 2, 1, 0, something like that. So etc. These are the some strings to form the alphabets using the alphabet set which is 0, 1. That is a alphabet set. This is the binary alphabet. Why you are saying it is all binary alphabet? Because of it is a 0, 1 is present. Set of strings. So set of strings means string. What is a string? String is a collection of characters, right. A language set of strings, or we can say it is a language. What is a string? String is a collection of characters. As like we represent 0, 1 is a one string, 1, 0 is a one string, 1, 1 is a one kind of strings. So this one we can say in a language in a TOC is set of strings over alphabet. For example, you could take the here example A comma B. A comma B is a one set of strings, one set of alphabet if you consider. What is the possible strings? A, AB, ABB, double A, B. These are the strings. We can say it is a one kind of language. This means language L contains the all specific kind of strings, right. So next one, empty set. So what is a empty set? Empty set is denoted as a pi, empty set denoted as a pi, and here it is a empty set. That means that simple we can say it doesn't have any elements in a L equal to pi. So this is a empty set. This means language L have no valid strings, that is a empty set. So we can see alphabet set, language set, empty set. Alphabet set is a 0, 1 symbols used from strings, right. Next one is a language set. Language set is a AB, ABB is a collection of strings. It is a collection of strings, right. Empty set, which is represented pi, does not contain no elements. This is the major difference between the alphabet set and language set, empty set. Next, going to the other detail, definition of the automata. So now we see the formal definition of the automata. Automata is a mathematical model for computation, right. It is a one kind of computation model. It describes machines that read the input symbol one by one and changes its states according to the predefined rules. That means that automata is a mathematical model of computation, right. It is a mathematical model of computation. It describes the machines read input symbol. That means that it describes the machine that read the input symbol. So it will read the input symbol one by one and it will change the state based on the input symbol, that to be according to the predefined rules. That means that there will be some rules, based on that rules it will change. Now you can see formal definition, M equal to phi tuple, that is Q sigma delta Q naught comma F. So these are the phi tuple entity where Q is a finite set of states. That means that automata having some finite state, whereas you can see Q naught is a starting state. That means that it is a kind of mathematical model which will have some starting state, some ending state. This is a Q and Q naught. There will be some starting state, there will be some ending state, right. So after that one, sigma is a finite set of input symbol. So that means that if transition is moving from here to here and here to here, something like that, there will be some input symbol. Just now we discussed it will change one state to the another state by using the predefined rules and input symbols. So that is a input symbol, that will represent as a sigma, whereas delta is a transition function. So transition function means how it is moving from one state to the another state. You will get a clear idea in a after a few minutes, right, from one state to the another state. So now you can see transition function, mathematical function, where delta starts Q into sigma, where derives the Q. That means that what is Q? Q is a finite states. There may be some one state with input symbol sigma, which goes to the another state, which is any of the state into the automata. That means that if it is transition is moving from one state to the another state, definitely it having some state to the input symbol. It may go to the same state and it may go to the some another state. It not necessarily be the same state. That's why they written as a Q cross E derives Q. And next one is a Q naught. Q naught we already discussed. It is a final starting state. That means that where it is starting state. F is a set of final accepting state. So we will see one example based on this definition. You will understand more clear information. Next one, language acceptance. So language acceptance is automata. It describes the which strings of automata accept, that is which, simple we can say, no need to read out much more definition. Simple, if you write some strings like a, if it is starting state is some state, it is going to the some ending state using the a input, then that string is accepted. So now you can see where L of M is a language which having machine, language accepting machine M equal to W belongs to epsilon star. Here it is a W is a string, any string like a. If I take here you can take 0 1, you take 0 1 string means here it is a 0 is a 1 string, 1 is a 1 string, 1 1 is a 1 string, 1 0 is a 1 string, etc. like that. Here it is a W is a string, any string that belongs to the sigma star. Sigma star means language which include the all strings, whereas delta naught is a transition on Q naught state W belongs to the F. Simple funda you can see here. Here we taken 0 1 is a input string, right? 0 1 is a input language which belongs to the W. So what are the strings will come? These are the strings will come 0 0 0 1 1, something like that. So what is the language here? Language which says W is a string ends with 1. So that means that if you write any string which belongs to the language L which end with 1 1 0 1 0 0 1, something like that, it will, this language will accept. So what it will reject? If string which ending with 0 will accept. That means that if it is going to the final state, it will get accept. If it is not final state, it will get reject. We will see the one example so that you will understand very clear. So next one is a finite automata examples. Now we will see the one finite automata example. As per our discussion, there will be one starting state, there will be one ending state. So starting symbol will be represented in the form of arrow symbol with circle notation, whereas a final state will represent in the form of double-ended circle. So now you call it as a, this is a one Q state, that is Q naught state. Now this one we call it as a Q1 state. Simple, not necessary to call it is like this is a Q naught, Q1, ABC, any name you can call, there is no problem, but simple I put Q naught and Q1. Q naught is a starting state, Q1 is a final state, right. So now you can take the language as a language, whereas a language as a 0 comma 1. That means that it will accept the 0 comma 1 as a input symbol. So now you take transition from Q naught to the Q1, right. How you will represent transition symbol? With using the arrow symbol of 0, right. So now you take the one more transition from Q naught to Q1 to the Q naught is a 1, right. Now you tell me, so based on the what is the input symbol? Starting state is a, sorry, what is the input symbol? Input symbol is a 0 comma 1. What is the starting state? Q naught. What is the ending state? Q1, right. So now what is the language accepted? Language accepted by the this automata is 0. Now you see starting state is Q naught, it is reaching to the Q1. It is Q1 is a final state. So that's why 0 is accepted. Now take the 0 and 1. 0 1 is accepted, not accepted, because of 0 is starting state, sorry, Q naught is a starting state and reaching to the Q1, and it is Q1 to the transition, it will go to the Q naught. Q naught is a not a final state, so it is string is not accepted, whereas 0 is accepted, right. This is not accepted. Now you take 0, again 0, again 0 will come? No, because of, you see here 0 is starting, Q naught you are starting, 0 will coming here, there is no existence of transition again. So the double 0 will not come. So, it will not accept. So, now you take one more 0, 1, 0 accepted, yes, it will accept. Now, you take 0 and again 0. So, it will get accept. Now, you take one more 0, 1, 0 accepted, 0, 0 will come here, starting 0, 1 here, 0 accepted, yes, it is accepted. So, that means that string ending with 0 is this automata is accepting, right. So, now you take one more automata, this is the one state, that is A, you take one more automata, you take B, same language you take, A is a make the starting state and final state. Now, you make the this is 0, this is 1. Now, you check it, previous example, 0 is reaching final state, no, here starting state, no final state, it is not accepting. 0, 1, 0 and 1 is reaching to the final state, it is accepting, right. So, it is accepting. Now, you take the 0, 1, 0 accepting, no, because of you see 0, 0 here, 1 here, 0 here, it is not at all accepting because of it is not reaching to the final state. Now, you take the 0, 1, 0, 1 accepting, check it. So, 0, 1, 0, 1 accepting. So, because of it is reaching to the final state. So, that means that language we just now we discussed now previously, this one which we discussed, this is the automata. See, language LM which is accepting the 0, 1 ends with 1, W is ending with 1. So, W is ending with 1. So, this is the automata which is accepting. Now, we will see one more example. Now, examples of finite automata. Now, you will see here. So, first one, what is a starting state? S1 is a starting state because of it is have arrow symbol and it is also double ended circle. S1 is a starting state and final state both, right. So, now you can see here there will be some arrow symbol which is a self loop. That means that where is a transition is starting, it is going to reach the same state, right. Now, you can see one transition from S0 to the S1, it is a one transition with input symbol is 0, S1 to the S2 to the S1, this is a one transition, 0 is the input, here it also self loop is a 1, right, it is a 1, here it is a 1, right. So, now we have to find the what type of language it is accepting, right. Now, you check. So, starting state is a now you can see starting state is the S0, right, starting state is the S0, right, and it is reaching to the S1 with the input symbol is 0, right, input symbol is 0. Input symbol is 0, whether it is going to the final state, it is not going final state. So, it is not at all accepting 0, 1. So, next you take 0, 1, 0, 1 is accepting starting state. Do not confuse here, do not start from S2 because of any string it must starting from 0. So, now you take the 0, 0 means it is starting state, come to the S2 state. Next one means it is going to the S1 which is a final state which is a accepting, right. Similarly, you take one more string 0, 1, 1 is accepting. Now, you check 0, yes, it is reached to the S2, then S1 again try to check properly, S1 starting with 0, right, reached to the S2 and again 1 is the input symbol, again S2, again 1 is the input symbol, again S2. So, string is not reaching to the final state, it is not at all accepting. Now, you check 1, only one input symbol. So, now you check the one input symbol, S1 is the starting state and self loop, you take the self loop, it is again 1. So, 1 is accepting the state. So again we check the one more again, 1 again one more 1 again one more 1 is accepting, it will get accept because of it will 1 again 1, it will be remain a loop. So 1 is again it will get accepted. Next you check 0 0 again 0, it will get accept. 0 0 0 again 0, it is not reaching to the non-final state, so it will not get accepted. If it is add the 0001 again 0, it will get accept because of 0 again 20 30 40, so it is reaching to the final state, it is getting accepted, right. So now you see 00 is accepted, check it once, 0 is accepted, again 0 is accepted. That means that single 0 00 is accepted, 40 accepted. Now check it 60 10 20 30 40 50 60 accepted. That means that 6 zeros are accepted. That means that 20 40 60, now you check it 8 zeros also accepted. That means that multiple of 2 zeros are accepting, 20 40 60 80 10 0 12 0, you can check it. So any number of zeros with even number, it will get accepted. That means that language L is equal to W, whereas W belongs to the even number of zeros, it will get accepted. So now we will go to the one more example. Now you check this one more example. Now what is the starting state? Starting state is a Q naught. So one fundamental principle we have to remember here. One thing is, that is, if you give any string, if it is reached to the final state, then it is accepted. If it is to the non-final state, it will not get accepted. These principles you have to remember. So what is the non-final state, final state here? What is the final state? What is the final state here? Final state is a Q2. Q2 is a final state. What is the non-final state in this automata? Q naught, right? Q1 is a non-final state. That means that if you are giving any input symbol, if it is reached to the final state, it is accepted, right? Now you check it, 0 1 0 0 1 0, it is reaching to the final state, so it is accepted. Now you check it one more, 0 0 1 accepted, 0 0 1 accepted, right. Now you check 0 0 again 0 accepted, check it, 0 again 0 again 0 1 0 2 0 3 0, it is not at all accepting string, right. So now you go check it one more string, 0 1 accepting, yes, it is accepting, we already checked it, 0 1. Now you check 1 1 0 1 accepted, 1 again 1 0 0 1 accepted, right. So next one, 1 1 0 0 1 accepted, 1 again 1 again 0 again 0 again 1 accepted, right. You take one more thing, 1 0 1 0 1 1. Now you check it, 1 0. Now you take 1, again you take 0, first instance, second instance 1, again 1. So it will get accepted. That means that here it is a 0 comma 1 means 0 or 1 meaning. So input string may be the 0, maybe 1 is the input symbol. So that is the meaning, right. So in this way you have to understand the automata. So simple, we will discuss the more details in further classes. Simple funda, if you are giving any input string, if it is reached to the final state, if it is reached to the final state, the automata string is accepted. If it is reached to the non-final state, automata string is not at all accepting the string, right. So simple funda and easy understanding. If it is the final state, it is accepted. If it is non-final state, it is not getting accepted, right. So we are seeing many examples, right. So remaining examples about this one we will discussing in the upcoming session. So thank you for watching. If you like the content, please subscribe my channel, share to your friends and needy people. Thanks for watching.